Hello and welcome to my presentation on orchestrating red team operations safely for both the offending and also the defending teams. My name is Yiannis Ioannides and I am the Cyber Risk Services Director at Deloitte Cyprus. And during the last 11 years I have been with Deloitte. I have been involved with many projects across multiple domains. You can find me often on Twitter, which is my primary source of learning the latest tips and tricks around information security. I try to maintain a blog, and I really enjoy presenting and attending as many conferences as I can and giving back to the community as much as I can. So I would like to thank Besides Athens for this opportunity to present. Before we begin, let me start by saying that this presentation is not about best practices and not the Bible on how you should operate. This presentation is aimed at giving you some ideas on how you should operate during red team operations to be safe and to also protect the client's data while we're doing this assessment. Because of the time, it's not feasible to cover every single technique or every single aspect of a red team operation. Therefore, some things are skipped, but I'm giving out links at the end of the presentation. And it's also very important to note that the techniques that I'm going to present have been first documented by other people, so please be so kind and give the appropriate credit where credit is due. And let's dive into the presentation. When we're designing the infrastructure prior to starting the operation, we have to choose on the model that we want to operate under. So in essence, there are three different models to choose from. One being the fully cloud model, where everything related to the infrastructure of our operation is online on cloud servers. Then we have the self-hosted model, where everything is the opposite of the cloud model. Everything is hosted on-site. And lastly, we have the hybrid model, where we have some critical servers in-house, and then we have some cloud redirectors for handling the traffic. We usually operate with the hybrid model, which is the one I'm going to present today. Because I mentioned redirectors, and it might not be a familiar term to everybody, when we say redirectors, we basically mean servers located in the cloud, where their only task is to receive traffic from our client and send it over to our infrastructure. So they take the traffic, send it back and forth. So in reality, they hide the actual IP space of our operation. So our client will not be able to block our command control server, but instead they will be able to block the redirectors. But then again, we can spin off new redirectors and then continue the operations, thus allowing the operation to continue without stopping immediately at least. Redirectors can be chained, so we can use multiple redirectors in a row, and we can make it as complex as we want. But in this example, I assume that you're using one redirector for every aspect of the operation. So one for phishing, one for payload delivery, and so on. So this is how the infrastructure is going to look like, where in the blue space, let's say this is DigitalOcean, we have 6 different servers, and we have 3 different domain names pointing to these servers, depending on the actual stage of the operation. So for the phishing side of things, we use one domain, one server being for the mail server, who is going to be responsible for sending the phishing emails, and then we have another domain who is hosting the phishing payloads. Then we have DNS and HTTP redirectors with 2 different domain names. So if the client blocks one of the domain names, then we have another domain name to utilize and remain active in our operations. And all the traffic ends up on our in-house command control server. But we're not limited into using just one cloud provider. We can use 2 or 3 or more depending on our needs. In this example, I have 4 servers being in DigitalOcean and then another 2 servers being on a different cloud provider. The reason for splitting up the infrastructure like this is, for example, the client sees that there is traffic which is unexplained going to DigitalOcean. So they see a spike in traffic going to DigitalOcean. They might decide to block the entire IP space of DigitalOcean while they investigate. But from our side, we still have a secondary channel to continue the operation via a different cloud provider. As you can understand, it will be very hard for clients to block everything. Therefore, we remain active until we find another way to operate, spin up new redirectors, and continue the operation. We can harden our infrastructure even more using iptables, for example, where we know that only our command and control server is supposed to be connecting to the redirector via SSH. So, since we know these parameters, we can have a rule specifying that for port 22, we want to accept traffic only from a specific IP, which can be mentioned in the rule. Now, we also know that our payloads work over specific ports. Those ports are either 53, 80, 443, 80, 80, or whatever else you configure your ports to use. If we also know the IP space of our client, we can also specify that. So in this example, we see that we accept TCP traffic on these ports only from this IP range. If any other IP which is not part of this IP range requests any of these ports, their traffic will be dropped. And we also have another rule to accept UDP traffic for 53 for DNS traffic, again specifying the IP range of our clients. Now, I know that in this example we might miss many targets just because we have people traveling or people over data connection or on their mobile devices, for example. But this is a risk that we're willing to take rather than exposing things that we don't want to expose, because sometimes our infrastructure is client specific, so we might use logos, for example, of our client, so we don't want everybody to know that there is a red team assessment or a phishing assessment happening for this client at this stage. And I believe it's our responsibility to also monitor our infrastructure the way that we expect our clients to monitor their infrastructure. So what we do is that we gather a lot of logs from all of our endpoints and all of our cloud redirectors in order to make sure that the traffic that is hitting the redirectors and our infrastructure in general is the traffic that we want to accept. And if it's traffic that was accepted and we don't need it or we don't want it, then we can take corrective measures and change our configuration to ensure that only the authorized people get to see the resources that we want to share, which are valid for our red team infrastructure. And what we do next, instead of actually being the blue team, we use some other tools to help us. So instead of just looking at the logs and doing threat hunting while we do a red team operation, we want to be alerted if something happens out of the ordinary, that is. So we use bash scripts to check the logs, and if they see anything strange, they send it over to Slack. So we know that if we receive a Slack alert, there is most probably something wrong happening. Or, as you can see from this example, we have the root user that logged in on the command control server. So if we know that we are the root user and we're not supposed to be connecting and it's not us, then we take corrective measures. We know that we have been compromised, that is. As I said before, what I showed you is a very simplified example of monitoring. If you really want to have a full-blown CM, I would urge you to check out Red Elk by Outflank. They have done a fantastic job in developing an actual CM to be used during red team operations. Sometimes this is too much depending on the operation type, but it's something you should definitely check out. So moving to the traffic that will be reaching our redirectors, and more specifically HTTP and HTTPS traffic, we can make use of something like Apache mod rewrite, which does URL manipulations on the fly. And what we can do is something like the example that I have here, where we have a condition saying that if the user agent is one of the user agents in the list, then redirect the user to google.com, or if the user agent is not one of the user agents in the list, then send them back to our backend IP and the request URI that they ask for. So why do we do this? So if we're having an assessment and we know from our intelligence that our client is a Windows-based client, so they use Windows, Microsoft Windows, we know that their user agent shouldn't be one of these. We also know that some clients, if we send them a phishing email, may try to open it from their mobile phones. And then again, you have search engines which index the domains, and we definitely don't want our phishing pages to be indexed. So if the user agent is one of these, user goes to google.com, the URL on the bar changes to google.com. If not, the information is going to be fetched from our backend IP, but the URL on the URL bar will not change. So our backend IP again will not be exposed. This is a final example of Apache mod rewrite, and it's really cool because again, if we know the IP space of our clients, we can specify it in the condition. So if there is traffic coming from IPs other than the ones that we mentioned here, so one range or the other range, users go to Google. So let's say search engines or anyone else scanning our domain, but users coming from the IP space of the client will be sent to our backend IP, again acting as a proxy. Therefore, just the information is coming from the backend IP, but the URL is not exposed. So let's move to other types of redirecting traffic, and we're going to talk about socat, which is a very nice tool and it's a very versatile tool where we can send traffic back and forth on our servers. The first example, it's a very easy example where we just accept for connections on port 80 on our cloud redirector. So we just say listen for any type of traffic coming on port 80, and when you see that type of traffic, send it over to our backend IP on whatever port we specify. So the first example, we listen on port 80 and we send it to our backend IP on port 8090. And the communication works like that. Again, we can use a reverse tunnel for the communication where our command and control server connects back to the redirector. And on the redirector, instead of sending the traffic to our IP, it will send the traffic to itself, where it's going to be picked up by the reverse SSH connection. We can harden socat even more by specifying an IP range. As with all the other examples that I mentioned before, we can use the IP space of our clients. So in this example, we say that we want to accept traffic on port 80 only from a specific range and send it over to port 8090 of our command control server. All other traffic coming from different IP spaces is going to be dropped. Because socat it's very versatile and has a lot of flags, I will urge you to visit the link on the page. It's a very detailed blog post about socat and will show you a couple of more tips and tricks. So let's go through the communications and see it in a little bit more detail using this example, where we have the internal network. This is the red team network, consisting of the command and control server and another server hosted in-house. Of course, these servers are not directly internet accessible and they're behind a gateway. And each of these servers is responsible for initiating a reverse SSH connection on the same cloud redirector. The reason is that one of these connections is going to be accepting traffic on port 80 and the other one for payloads running over port 443. So as you can see, the first connection is made on port 2222 and the other one on port 2223 on the cloud redirector. So what happens is that our victim will request either an HTTP or an HTTPS payload. Socat is running on the cloud redirector, sending the traffic to itself as we discussed before. So traffic coming to port 80 is being sent on port 2222, and any traffic coming on port 443 is being sent on the local host on port 2323. So the redirector will accept that traffic, send it over to our gateway, and the gateway will send it over to the responsible server for serving the payload. DNS traffic is a bit trickier just because the reverse SSH connection is TCP based and DNS is UDP based, and therefore we have to do some additional steps here. And for this reason, the traffic we receive on the redirector will be translated to TCP. So UDP coming in will be translated to TCP and sent over the reverse SSH tunnel. On the in-house server, we have another instance of socat running, taking in that TCP traffic and converting it back to UDP in order to be used as DNS as it is. We can do something similar with iptables, although iptables it's sometimes more complex to use and easier to get logged out from your server if you make a mistake, and I have done many of those. And I try to use, and I prefer to use actually, Firehole, which is a tool that has a really nice feature which explains the rule before applying the rule. But again, here we're accepting UDP traffic on port 53 and send it over to our command and control server on port 53. Something I don't see being discussed a lot is about data at rest. So data that has been collected during the operation and has to stay on one of our servers for some period of time for whatever reason. And Linux has a lot of tools, but I have found that Tomb is working very nice. It's a very easy tool to use, and you can basically create a new tomb to keep your data, throw the data in there and keep it safely for as long as the operation dictates that you should keep it for. So again, something to keep in mind as well while running an operation. I have included the links from my blog, which I detail some of these techniques more, and then the blogs that of the people that I used their research for to compose this presentation. Make sure you visit their blogs, and they put out amazing information often. And closing, I would like to say a big thank you to B-Sides Athens and anybody who sat and went through this presentation, and I really hope to see you in person in 2021. Thank you very much.